Hello and welcome! Today we will be learning how to make a dilution. So, what is a dilution, you may be wondering? Well, let's start by first defining stock solution. That is the solution that we will use for the dilution. We will dilute the stock solution with, in this case, water to create a less concentrated solution. This less concentrated solution is the dilution.
Here, my colleague, Alan Tucker, transfers the stock solution to another vessel for pipetting. To find the concentration of the dilution we are making, we will use the equation C2 equals C1 times V1 over V2. In the next part of this experiment, we will talk about finding V1, which is the amount of stock solution used in the dilution. Here, I transfer stock solution from the beaker into the volumetric flask. First, I read the initial volume out to Alan as I look at the meniscus. I put some in the volumetric flask and then read the final volume to Alan. The final volume minus the initial volume will give us the volume of the stock solution used in the dilution. This is V1.
When determining the initial and final volumes of the 20% stock solution in the pipette, it is important to read at eye level the bottom of the meniscus. The meniscus is the curve seen at the top of a liquid in a container, caused by the molecules of water being more attracted to the container than each other.
Now we must dilute the portion of the stock solution put in the volumetric flask with the blue water. We must fill the volumetric flask with blue water up to the 25 milliliter mark, with the bottom of the meniscus resting perfectly on that mark. Here, in the lab notebook that Alan wrote the final and initial stock solution volumes in earlier, we keep our data and complete our calculations. Now we must solve for C2. We know that C1 is 20, as we had a 20% stock solution, and we discover after subtracting the initial volume from the final volume that V1 is 4.18 milliliters. V2 is 25 milliliters, as the volumetric flask contains 25 milliliters of dilution. After we plug the numbers in, we find that the dilution is 3.34% solution, which is C2. Now that we have collected our data and finished our calculations, the most important thing is to clean up after the lab. All the glassware must be soaked, rinsed, dried, and put away. Here, Alan, Austin, and Cece clean up, content that they have knowledge to make a dilution.